Welcome friends. In the previous session, we discussed the Euler's predictor corrector formula to solve the differential equation of the form dy by dx is equal to f of xy given that y of x naught is equal to y naught. Here we shall discuss another powerful predictor corrector method, namely Milne'S predictor corrector method. If we want to find the value of y m plus 1 using this method, knowledge of 4 immediately preceding values of y, namely y m minus 3, y m minus 2 and y m minus 1 and y m is required. Though it appears a disadvantage, this method is advantageous as both the predictor and corrector formulas have the error of order h raised to 5. Let me derive the Milne'S predictor formula. We have Newton's forward interpolation formula. Z is equal to z naught plus u into delta z naught plus u into u minus 1 divided by 2 factorial into delta square z naught plus u into u minus 1 into u minus 2 divided by 3 factorial into delta cube z naught plus etc. Here z is equal to dy by dx, that is y dash. Z naught is equal to y naught dash, delta z naught is equal to delta y naught dash, etc. U is equal to x minus x naught divided by h, or we can write x is equal to x naught plus u into h. We integrate both sides of this expression with respect to x between the limits x naught and x 4. We have y 4 minus y naught is equal to h into integral from 0 to 4 this expression z naught plus u into delta z naught plus u into u minus 1 divided by 2 factorial into delta square z naught plus etc. du. Because dx is equal to, from here we can write dx as h into du, and the limits for u are 0 and 4. Now, integral from 0 to 4 du is equal to, here first term is integral 0 to 4 z naught du. We evaluate separately. We can write integral from 0 to 4 du as 4 is equal to 4. Integral from 0 to 4, delta z naught is a constant, therefore we want to integrate integral from 0 to 4 u du, which is equal to u square by 2 between the limits 0 and 4, which is equal to 8. Integral from 0 to 4, this term u into u minus 1 divided by 2 factorial du, which is equal to 1 by 2 into integral from 0 to 4. Here 2 factorial is 2. Therefore, we can write 1 by 2 into integral from 0 to 4 u square minus u square minus u du. On integration, we will get is equal to 1 by 2 into u cube divided by 3 minus u square divided by 2 between the limits 0 and 4. This is equal to 1 by 2 into 4 cube divided by 3, that is 64 divided by 3 minus 4 square divided by 2, that is 16 divided by 2. On simplification, we will get this as 20 divided by 3. Integral from 0 to 4 u into u minus 1 divided by 2 factorial is 20 divided by 3. Integral from 0 to 4, the next term is u into u minus 1 into u minus 2 divided by 3 factorial du. On integration, we will get value of this integral as 8 by 3. The next term is integral from 0 to 4 u into u minus 1 into u minus 2 into u minus 3 divided by 4 factorial du, which is equal to on simplification, we will get value of this integral as 14 divided by 45. Using these values, we can write y4 minus y0 as, from this expression, on substituting all these values, we will obtain y4 minus y0 is equal to h into, first term is integral from 0 to 4 z0 du, that is 4 du. This is the value of first integral, that is h into 4 z0 plus the next integral is integral from 0 to 4 u into delta z0 du. Therefore, from this we can write 8 into delta z0 plus next term is 20 divided by 3 into delta square z0. Next term is 8 by 3 into delta cube z0 from this, and from this expression we can write 14 divided by 45 into delta raised to 4 z0 plus etc. This is equal to, we can write this as h into 4 z0 plus 8 into e minus 1 of z0. In the finite difference, in the topic finite differences, we derived that delta is equal to e minus 1. We derived the relation between the forward difference operator and shift operator e, that is delta is equal to e minus 1. Therefore, we use the result here. We can write 8 into e minus 1 of z0 plus 20 divided by 3 into e minus 1 square of z0 plus 8 by 3 into e minus 1 cube z0 plus 14 divided by 45 into e minus 1 raised to 4 z0 plus etc. This is equal to h into 4 z0 plus 8 into e of z0 means z1 minus z0 plus 20 divided by 3 into e minus 1 whole square of z0 means e square z naught minus 2 e z naught plus z naught. E square z naught means z2 minus 2 times e z naught. E z naught means z1 plus 1 is z naught, that is z naught, plus 8 by 3 into expanding e minus 1 whole cube and applying the shift operator, we will obtain 8 by 3 into e cube z naught. E cube z naught means z3 minus 3 times z2 plus 3 z1 minus z naught plus 14 divided by 15, sorry 14 divided by 45 into, here we use delta raised to 4 z naught. And so on, plus etc. This is equal to h into combining all the terms having z naught, we can write 4 z naught plus minus 8 z naught, here 20 divided by 3 z naught, in this minus 8 by 3 z naught, that is 4 minus 8 plus 20 divided by 3 minus 8 by 3 z naught, plus now we grouping all the terms having z1, we can write 8 minus 40 divided by 3 plus 8 into z1, plus similarly the terms having z2, which are 20 divided by 3 minus 8 into z2 plus 8 by 3 z3 plus 14 divided by 45 delta raised to 4 z naught plus etc. This is equal to h into 8 by 3 z1 minus 4 by 3 z2 plus 8 by 3 z3 plus 14 divided by 45 into delta raised to 4 z naught, this into h plus etc. That is equal to, we can write this as 4h divided by 3 into 2 y1 dash minus y2 dash plus 2 into y3 dash. Taking 4 by 3 as common, we can write this expression as 2 z1. z1 means y1 dash. Here minus z2. z2 means y2 dash. In this 2 by 2 z3. z3 means y3 dash plus 14 divided by 45 into h into delta raised to 4 z naught. Z naught means y naught dash. Plus etc. We neglecting the fourth and higher order differences, we can write this as 4 h by 3, here y4 minus y naught. This is equal to 4 h divided by 3 into 2 y1 dash minus y2 dash plus 2 into y3 dash this is y4 minus y0, therefore, we can write y4 as y0 plus this term, y4 is equal to y0 plus these terms. Here the error is 14 divided by 45 h into delta raised to 4 y0 dash plus etc. If we integrate the first expression, that is the expression for y4 minus first expression between the limits, that is the Newton's forward formula. If we integrate the Newton's forward difference interpolation formula between the limits x m minus 3 and x m plus 1. If we integrate in between x m minus 3 and x m plus 1, we will obtain the corresponding expression as y m plus 1 is equal to y m minus 3 plus 4h divided by 3 into 2 into y dash m minus 2 minus here y m minus 2 dash 2 into y m minus 2 dash minus y m minus 1 dash plus 2 times y m dash plus 14 divided by 45 into h raised to 5 delta raised to 4 z naught, that is y naught dash. Y m minus 3 dash. This equation is known as Milne'S predictor formula. That is for the calculation we use these parts as the Milne'S predictor formula, that is y m plus 1 is equal to y m minus 3 plus 4h divided by 3 into 2 y m minus 2 dash minus y m minus 1 dash plus 2 into y m dash. This is the Milne'S predictor formula. Now, to derive Milne'S corrector formula, we have to integrate with respect to x between the limits x naught and x 2. Preceding as before, we have y 2 minus y naught is equal to h into integral from 0 to 2 z naught plus u into delta z naught plus u into u minus 1 divided by 2 factorial into delta square z naught plus etc. du, which is equal to, after all the integrations, we will obtain this as h into 2 z naught plus 2 into delta z naught plus 1 by 3 delta square z naught minus 1 by 90 delta raised to 4 z naught plus etc., which is equal to h into 2 z naught plus 2 into, here delta can be written as e minus 1 of z naught plus 1 by 3 into e minus 1 square z naught minus 1 by 90 delta raised to 4 z naught plus etc., which is equal to h into 1 by 3 z naught grouping all the terms having z naught, we will get 1 by 3 z naught plus 4 by 3 z1 plus 1 by 3 z2 minus 1 by 90 delta raised to 4 z naught plus etc., which is equal to h by 3 into y naught dash, z naught is y naught dash plus 4 into y1 dash plus y2 dash minus 1 by 90 into h into delta raised to 4 z naught. Neglecting the fourth and higher order differences, we can write this expression as y2 minus y naught is equal to h by 3 into y naught dash plus 4 into y1 dash plus y2 dash. We neglect this fourth power and higher powers. We can write from this, we can write y2 is equal to y naught plus h by 3 into y naught dash plus 4 into y1 dash plus y2 dash. Here the error is minus 1 by 90 into h into delta raised to 4 z naught means y naught dash plus etc. In general, we can write the formula as y m plus 1 is equal to y m minus 1 plus h by 3 into y m minus 1 dash plus 4 into y m dash plus y m plus 1 dash. This formula is known as the corrector formula. The first one is predictor, Milne'S predictor formula. This is Milne'S corrector formula. Now, we have to do an example for this method. Using Milne'S predictor corrector method, find y of 2. We want to find y of 2. If y of x is the solution of the differential equation dy by dx is equal to 1 by 2 into x plus y, given that y of 0 is equal to 2, y of 0.5 is equal to 2.636, y of 1 is equal to 3.595 and y of 1.5 is equal to 4.968. Y of 1.5 is equal to 4.968. These are given. We want to find the value of y at x is equal to 2, that is y of 2, using Milne'S predictor corrector method. Here we have to take x naught as 0, because y naught is equal to 2 is given, means we take x naught as 0, x1 as 0.5, this is x2, x2 is equal to 1 and x3 is equal to 1.5, x3 is equal to 1.5. We want to evaluate y of 2, we take this 2 as x4, x4 is equal to 2. H is taken as 0.5. From this expression, from these values, we can write 2 as y naught. Y naught is equal to 2, y1 is equal to 2.636, y2 is equal to 3.595, and y3 is equal to 4.968. We want to find y4. The given function is, the given differential equation is dy by dx is equal to x plus y all divided by 2, that is y dash is equal to 1 by 2 into x plus y. Given that y dash is equal to 1 by 2 into x plus y. By Milne'S predictor formula, this is the Milne'S predictor formula, that is y m plus 1 is equal to y m minus 3 plus 4h divided by 3 into 2y dash 2y m minus 2 dash minus y m minus 1 dash plus 2y m dash. Putting m is equal to 3, we can write y4 as, substituting m is equal to 3 in this expression, we obtain y4 is equal to y naught plus 4h divided by 3 into 2 into y1 dash minus m equal to 3 means 3 minus 1, that is y2 dash plus 2 into y3 dash. Now y1 dash is equal to, in order to find this y4, we want y1 dash, y2 dash and y3 dash. y1 dash means 1 by 2 into x1 plus y1. We are given that y dash is equal to 1 by 2 into x plus y. Therefore, y1 dash means 1 by 2 into x1 plus y1, that is equal to 1 by 2 into x1 is 0.5 plus y1 is 2.636. On simplification, we will get this as 1.5680. Similarly, y2 dash is equal to 1 by 2 into x2 plus y2, that is equal to 1 by 2 into x2 is 1 plus y2 is 3.595, that is equal to 2.2975. Similarly, y3 dash is equal to 1 by 2 into x3 plus y3, which is equal to 1 by 3 into x3 is 1.5 plus y3 is 4.968. On simplification, we will get this as 3.2340. Substituting these values, we will get y4 as y4 is equal to y naught is 2 plus 4 into h is 0.5 divided by 3 into 2 into y1 dash, that is 2 into 1.5680 minus y2 dash is 2.2975 plus 2 into y3 dash. 2 into y3 dash is 3.2340. On simplification, we will get this as 6.8710. That is, the predicted value of y4 is 6.8710. Now, by using this corrector formula, we refine this predicted value of y4. This is the corrector formula, that is ym plus 1 is equal to ym minus 1 plus h by 3 into ym minus 1 dash plus 4 into ym dash plus ym plus 1 dash. Putting m is equal to 3, we will get note that this is our y4 predicted. Putting m is equal to 3, in this we will get y4 is equal to y2 plus h by 3 into, here h by 3 is common, so mistake, here h by 3 is common, therefore h by 3 into y2 dash, m is equal to 3 means 3 minus 1 is 2, y2 dash plus 4 into y3 dash plus y4 dash. Now, y2 dash in the in this case, we, in order to evaluate this predicted value of y4, we evaluated y2 dash and y3 dash. Now, we want to find y4 dash only. The values of y2 dash and y4 dash are, in the previous case, we evaluated y2 dash as 2.2975, y3 dash is equal to 3.2340. These two are already evaluated. Now, we want to find y4 dash. Y4 dash is equal to 1 by 2 into x4 plus y4. That is equal to 1 by 2 into x4 is, this is x4, that is the required value is x4, value of x is equal to 2, that is 1 by 2 into x4 plus y4, that is 2 plus y4 is taken as this predicted value, that is 6.8710. On simplification, we will get this equal to 4.4355. Therefore, y4 is equal to y2 plus h by 3 means y2 is 3.595 plus h is 0.5 divided by 3, h by 3, that is 0.5 divided by 3 into y2 dash is 2.2975 plus 4 into y3 dash is 3.2340. Plus y4 dash is 4.4355. On simplification, we will get this as 6.8732. This is the corrected value of y4, therefore, we use this notation y4c. The predicted value is 6.8710 and the corrected value of y4 is 6.8732. This is taken as the required value of y of 2, that is y of 2 is equal to 6.8732. With this example, let me conclude this session. Thank you for listening the class. Have a nice day.